All right, I think we'll make a start now. Thank you very much for joining this webinar. Really warm welcome. Delighted to be spending a bit of time showcasing some of the nature recovery decision tools, support tools that we've been developing over the last few years, really as part of the Renew project, which we be hearing a little bit more about in a moment. Firstly, just to say, great to see so much interest in this. Really, actually quite surprised by the level of interest in this and how many people we've had signed up for this, and delighted to spend a bit of time talking about it. David, could you just flick over to the next slide, please? So just before I sort of introduce the rest of the team, I'm just going to run through a little bit of housekeeping. So firstly, just to say that the webinar is being recorded. That's just so that people that join late or the people who are unable to attend can view it, and we're also very happy to make the presentation that we're going to give available to colleagues if you have colleagues that were unable to attend. Attendees' cameras and microphones will remain muted throughout the webinar, so we really do encourage questions though, but if you could put your questions in the Q&A up at the top. You should see a little button up at the top, and you should there be able to see the Q&A, and if you just write your questions, and then what I'll do is I'll read them out at the end, and we will handle the questions that way. And if you just switch over to the next slide, please, David. So just to do a few introductions, my name's Ilya McLean. I'll be chairing this webinar. I'm a professor, an ecologist by training. I'm based at the University of Exeter's Penryn campus in the Environment and Sustainability Institute. But actually, I'm going to be handing over to my team for giving the majority of the presentation. So firstly, David Baker, who's a postdoctoral research fellow in my team. And he's really the brains behind some of the decision support tools that you'll be hearing about. He'll give an overview of Ebrel. And I'll also then hand over to Marcus Rhodes, who's a postdoctoral research associate in my team, and he'll be talking about the other tool that we've developed, Rebio. And then I'm also delighted to have Philippa Hoskin along from Cornwall Council, and Beth Roberts, her colleague at Cornwall Council. And the reason really for bringing them along is that we've been working quite closely with them on the local nature recovery strategy in Cornwall, and we just wanted to really sort of demonstrate actually that some of the tools we're developing have a practical application. And both Pip and Beth have been excellent at keeping our feet on the ground and sort of reminding us that there's a real world out there we need to be thinking about. And so actually it's a really nice example of science and practice coming together. So we hope you find that interesting. And that's really all I had to say. Actually, I'll hand over to you, David, to basically give an overview of the tools.
Brilliant. Thank you, Ilya, and welcome everyone. It's an exciting opportunity to talk about our work and present to such a broad audience. I'm going to give a brief overview of the Renew project to start with. I know quite a few people online are probably partners or have been involved in Renew, but it's a big project, and I think it deserves a bit of an introduction. And then I'm going to talk a bit about the particular theme that we work on, and then go into detail about some of the work we've been doing. So the Renew project is a large 5-year NERC-funded project. It was a joint bid between the University of Exeter National Trust with 30 additional partners, employs about 70 researchers from research assistants all the way to professors, and It has a broad aim to renew biodiversity through a people in nature approach. And what is a people in nature approach? Well, it's the approach that Renew is taking is to realize and recognize that people are the key agents of change. We often know a lot about what to do for biodiversity from an ecology point of view. It's often getting people to do it is the hard thing. So we're interested in understanding the capacity and the drivers of change that shape that in realizing that people are shaped by their sort of history, the place and the culture, and how they imagine futures, and that really affects the capacity and the drivers of change. And we recognize also that change comes about through communities and through networks, and we're so interested in understanding, how networks can facilitate biodiversity renewal. So we take a whole systems approach, and we focus on the key challenges of understanding how to harness broad support for biodiversity renewal, and understanding how communities that are disengaged or disadvantaged or disconnected from nature can be enabled to benefit from biodiversity. Furthermore, we're interested in how we can design and deliver diverse sets of renewal activities through land managers or other interest groups, and that's some of the work I'm going to be talking about today. And then also understanding how biodiversity renewal can be embedded within finance and business. So kind of improving the sort of green financing as a complement to the carbon accounting. So through this approach, using this approach, we have 4 main themes in Renew. So we have an individual actors theme, which aims to understand how individuals relate to biodiversity and ecology, and how understanding the way they relate affects their behavior towards biodiversity renewal, biodiversity change. We have a community action theme, which is about trying to understand how to engage disadvantaged and disconnected communities and provide access to all to nature and the opportunities and benefits provided by nature recovery. We have a land managers theme, which I'm going to talk about further in a minute. And then we have a business and finance decision makers theme, which is all about trying to understand how business thinks about biodiversity and how we can enable them to make good decisions towards biodiversity. And then we have these cross-cutting themes, and the most relevant theme today for that is the environmental intelligence theme, which I'm also a part of. And we aim to use modern state-of-the-art statistical AI computing tools to take advantage of the wealth of data out there to drive and inform our decisions. We have an X cases theme, which is about short sprint missions to generate solutions for urgent questions in biodiversity. And then 2 themes, one focuses on collaboration in practice. So how do you collaborate to perform good research projects, and an equality, diversity and inclusion theme, which is embedded throughout Renew, and is important because we are interested fundamentally in trying to make nature recovery open to all. So I work on theme 3. This is a theme led by Ilya. Marcus and I work on this theme. It's focused on land managers. So the big overall aim of this theme is to enable pro-biodiversity land management decisions that account for competing demands on land. So we recognize that biodiversity is not the only thing needed from land, that we have to compete with production of food, net zero, etc. So we have specific objectives within this theme. So the first objective is to track changes in land use, habitats and species, so that biodiversity renewal decisions are based on the best available evidence. So that's a lot about trying to measure changes in habitat and environment conditions. It's also about trying to understand where species occur at the moment and where they might occur in the future, given conservation actions. Then we have a focus on integrating these competing demands for land into strategic conservation planning tools. So this is one of the things we're going to be talking about in depth today. And then our collaborators on this theme are social scientists specializing in working in farm landscapes, and they're interested in understanding the factors that determine the quality of renewal activity and how to facilitate co-design of nature positive actions on farms. And then together we're interested in testing how to actually embed these approaches into practice. And that's also what we're going to be talking a little bit about today. So we recognize in this theme that there's basically two divergent approaches. So we have these strategic approaches that we're interested in. So drawing on the principles of conservation planning to decide what to do in the landscape, where, and but we struggle here to integrate this knowledge into practice on the ground, because often our decisions are made at farm or field scale by land managers. And this is through a participatory approach where the land managers are the decision makers. And what we're trying to do here is in this theme, the grand challenge of this theme is to try and integrate these two approaches. How do we integrate strategic top-down approaches with this sort of bottom-up decision making? So hopefully we'll make some progress on that. We have a paper talking about this challenge and some solutions. So it's called Aligning Strategic and Participatory Approaches to Agri-Environment Scheme Design and Implementation to Enhance Nature Recovery Outcomes, if you want to read further about that. So that's an introduction to Renew and to our theme. And we've been working really hard in our theme around this idea of spatial prioritization, this top-down decision-making tool, a suite of tools, really. And we've been working with a team of ecologists and mathematicians. So we have Ilya and Professor Kevin Gaston leading the theme. And then I've been lucky enough to work with Marcus Rhodes, who's going to talk later, and also Dr. Siddharth Kumar, who is a mathematician working at the interface between mathematics and ecology, or mathematics and anthropology and geography. And we've been working together to develop novel spatial prioritization tools that really can work in our landscapes with the challenges we currently face. I've placed our email addresses here. Please feel free to contact us about any questions or anything you're interested in following up. So prioritizing conservation actions for nature recovery. So we have ambitious nature biodiversity recovery targets in this country. We have these probably because we're one of the most nature depleted countries in the world. We've seen huge declines in populations across a diverse range of species since we started measuring populations well. So we now have these targets to halt the decline of wildlife populations by 2030 and to increase the species abundance by at least 10% by 2042. So these are ambitious targets, and we're starting from quite a low point. Species, I think, are really important in this. We are interested in recovering species abundance. We have 943 species of principal importance, representing broad ranges of taxa, from algae to cetaceans. And these species we have legal responsibility to try and increase their abundance and make them fare better. We also monitor the changes in abundance through the species abundance indicator, which has 1,176 species representing a broad range of taxa. So we are really interested in increasing species abundance. And these species represent a diverse range of species with different habitat requirements, different requirements for resources and conditions, often highly specialized species, and often also highly localized. So I think this means that it matters a lot about where we do things in the landscape, and what we do where, in order to recover these species. And this links with the Lawton Review, Making Space for Nature Review, which came up with the term more, bigger, better joined. And this is, again, all about space. It's all about what we do where that matters. So Obviously, we require more habitats to support wildlife because we've removed a lot of habitat over the last several decades. But really, we also require bigger habitat. So that requires making patches bigger. So that is about where we build habitat patches, buffering existing habitat, adding to existing habitat patches, improving the quality of habitat patches. So acting where we can improve the quality, but probably in locations where we're already doing something for nature, and joining up existing habitat patches. So this is all about space. So we think that achieving these targets, these ambitious targets, requires a spatially targeted approach. It requires spatially targeting actions. And we've done some work just looking at the consequences of targeting versus not targeting actions. So here on the y-axis is the abundance index, and on the x-axis, the year. And our simulations show that status quo, so not doing anything additional for nature, we follow this precipitous decline into the future. But if we do untargeted actions, even quite a lot of untargeted actions in the landscape, just taking wins wherever we can, we basically follow the same trajectory, just a little bit shallower. But if we target our actions towards where we're already doing okay for nature, we make those sites better, bigger, and more connected, we can actually achieve the targets and halt declines with about half the land area. So not only are targeted interventions more effective, they're also more efficient. They're a better way of spending our resources. We also know that whilst there are plenty of opportunities for habitat creation in the landscape, it's not always clear where to do what. So we did some work with some farmers in Devon. We asked them about what opportunities there were for conservation actions on their land. And they came up with a wealth of suggestions and a wealth of opportunities, lots of actions they would like to implement. It was almost too much actions, and it's difficult to fund all those actions. So the critical question is, which actions should be prioritized and where? And this is why we've been developing our spatial conservation planning tools. And I just want to stop a second and just talk about systematic conservation planning. This is the framework within which these spatial prioritization models work. So systematic conservation planning is a decades-old method, a structured, participatory approach for guiding objectives and evidence-based decisions about the types and locations of conservation action. This method was historically used to prioritize where to expand protected area networks, and has been important because it is a truly participatory approach. You start off by consulting stakeholders, asking them what they want from the landscape, which species they're interested in, which other factors they're interested in promoting on the land. It then sets up targets, so it's target driven. So what do we want to achieve in the landscape? So for species conservation, we might want to increase the amount of habitat in the landscape for a selection of species. And then we can set targets to try and achieve. And then we use a selection process, a spatial prioritization algorithm, which is what we've been developing, to find those subset of locations that satisfy those conservation goals. So I want to emphasize at the beginning that we've developed a spatial prioritization tool, and it's a computer model, but at no point is the model the only answer. The people need to be involved in the process. So I want to emphasize that from the beginning. We wrote a paper about systematic conservation planning for nature recovery. It's published in Bioscience. The link is here and it's open access, should be freely available. So our model, Ebrel, so it's called Ebrel. Ebrel is Cornish for April. It's the month of biodiversity renewal. And we decided to call it this because we wanted to reflect the place in which the model was developed. We developed Ebrel to sit at the heart of a spatial systematic conservation planning process for nature recovery. The model is designed to guide spatial decisions about where to act in the landscape to recover species. And so it addresses this question here. What spatial configuration of conservation actions enable us to achieve our biodiversity targets while balancing other land use priorities? So here you can see we have a particular field, a particular land parcel. We might have multiple different options to choose, things we could do that will benefit different subsets of species and have different effects on ecosystem services or other co-benefits. And the model asks the question, what should we do in this and other land parcels to achieve these targets? The model objectives. So given a set of targets for species recovery, so for example, meeting those 10% increase in abundance targets for species in the UK by 2042, can we find a set of actions that can achieve those targets, whilst also minimizing the costs we spend on those actions, and also respecting the Lawson principles of more, bigger, better joined by minimizing the spatial disaggregation of actions? That's the overall aim. And here, because we're taking a very species-specific approach, because we feel like the needs of species are paramount here, we need to take account of species-specific habitat requirements in this model and their potential to move through the landscape from where they currently occur to potential opportunities we're creating in the landscape, so they can take advantage of those opportunities we're creating for them. The model also needs to account for spatially varying actions, spatially varying costs and action-dependent costs. So, for example, it might cost more to plant a woodland than create a species-rich grassland, and those costs might vary over space. And if we have finite resources, which we tend to do in conservation, we need to account for those in the model. And then we also need to accommodate the co-benefits or potential co-benefits of nature recovery actions. So nature-based solutions for flooding, for example, or carbon sequestration, or thinking about equitable access to nature. So when we're making our decisions for what to do where in the landscape, can we also account for these other factors that society values? So those are the grand objectives. The key principles guiding this approach are that it is, first of all, a target-driven approach. We set specific targets for species. We want to achieve particular targets. So, for example, increasing the available habitat area by 30% for each species. Representation is important. So finding solutions in the landscape, finding a set of actions in the landscape that actually provide for all of the species we're interested in, not just a subset. We want to ensure that all the species that society values, that we think are important, are represented in our landscape, in our set of actions. So we're ensuring that all the species are covered by the opportunities we're providing within the region. And then the model operates on the principle of complementarity. What you're seeking to do is find sets of conservation actions that contribute different sets of species to the portfolio of species you're representing across sites. So rather than picking sites that only contain the same species, you want to pick sites that provide opportunities for multiple and differing suites of species. This complementarity is important because it leads to efficiency by providing opportunities for multiple species to exist in the same site at the same time. You lead to solutions that are more compact, that have lower resource requirements and are more efficient in general, efficient in terms of both costs, financial costs, land area costs, or whatever else we're valuing in terms of costs. So those are the principles. So how does the model work in practice? Well, first of all, we have the data inputs, and what inputs do we require? Well, we require information, first of all, on what we call the feature layers. So they're the species and existing habitats we're interested in. So we require mapping the species distributions as they currently are found across the region of interest. And this might be done by using existing occurrence records or species distribution modeling or expert opinion. But those species need to be mapped to whatever scale, grid resolution you're operating at, whether that's a grid or field parcel scale. And we also need to know where existing habitat occurs. We then have what we call habitat opportunity layers. And these are maps of the same resolution as the feature layers that represent the types of habitat you could create on a particular land parcel, given the soil, the hydrological conditions, the climate conditions. And we would have one layer, one raster layer for every particular opportunity. So that might be a woodland creation layer, a heathland creation layer, a species-rich grassland layer. And that tells us where it is possible to restore or create that type of habitat in the landscape. We then have, and by the way, so the way we can produce those is often, we've produced those layers by matching up the habitat, the national vegetation classes to the types of soil and hydrological conditions available in the landscape. So we then have cost layers. So the cost layers reflect the spatial, but also the habitat specific costs of any action in the landscape. So restoring woodland might have a particular cost, but that cost might also vary across space. And then we have information on unavailable locations. So locations where we can't create something because of, for example, the conditions aren't right, or it's an urban area, or it's the ocean, or something like that. And then we have the species trait information. So this is information that we call a species by habitat opportunity matrix. So that indicates for every species we're considering in the spatial prioritization, whether the species can take advantage of that habitat. So this might be a binary layer, so 0 if it can't use that habitat and 1 if it can, or it could be a continuous value between 0 and 1 that reflects how favorable the habitat is for the species. And that sort of information is extracted both from the literature, but also consultation with species experts. We then have information on dispersal distances. This is important because our model must consider how species move through the landscape. So those dispersal distances are usually the maximum distance we expect the species to be able to disperse between patches. And then we have a set of species recovery targets, so a target for each species. And that target is usually informed by a policy or stakeholder interest or engagement. So, for example, the layers might look something like this, where you have information on the existing habitat. So we have wet woodland here and lowland heathland here, and then a map of where the species could occur. And you might have multiple species at one site, you're likely to. So you'd have multiple species potentially occurring in any particular grid cell. And those features are represented in these raster layers. Then we have the habitat opportunity layer. So that will indicate for each land parcel or pixel where we could create a particular habitat. And in many cells, you'll have like multiple potential actions per land parcel. So here, this grid cell, maybe we could create wet woodland, but also lowland heathland. And those again are represented in these raster layers. We then would understand, without considering dispersal, we want to understand the types of habitat every species could use. So the lookup table, the habitat by species matrix can be used to tell which species could take advantage of any particular opportunity in the landscape. And finally, in this setup phase, we have the cost layer, which might reflect different costs depending on, for example, the grade of agricultural land or the value in terms of crop production or opportunity for development, etc. So we'd have one for each habitat layer, and these might reflect low, medium to high costs, but it will be scaled between 0 and 1. We can also include positive cost factors, so this might be benefits of a particular action in a particular location. So, for example, a particular location might be beneficial to put somewhere because it has flood mitigation implications. So once you've set up the data, the first step in the model is to randomly select a set of permissible actions in the landscape. So actions towards recovering species. So actions to create or restore particular habitats. So this can be either completely random or it can be informed by a priori understanding of the landscape. So one scenario we use is to weight the selection of potential options towards existing habitat. We then, using that selection, we calculate the costs of that solution. So we basically add up the costs across all those proposed actions. We then calculate how spatially coherent the selection of actions are with respect to both existing habitat and also other potential actions you've suggested in the landscape. And this is where we capture the more, bigger, better and joined component of Lawton principles. So for example, here, what we're interested in is calculating some metric that measures the connectivity or the aggregation of these patches. And so this is, in this model, it's a spatial function that takes a smaller value the more aggregated the solution is. And I put this equation here, not because I'm interested in showing the equation, but because my colleague Siddharth was so worried that people would be intimidated by this equation. He actually wrote this in the paper. He said, it might look intimidating, but it is actually quite simple, and it's true. Basically calculating the interpatch distances between all these patches, and the more aggregated, the lower value you get. So in this second solution over here, we got a more compact solution, we get a smaller value. We then calculate the contribution of the selected actions towards the species conservation targets. So here we have multiple species. We have silver-studded blue occupying these heathland patches, this heath threadwood occupying these other heathland patches, and these willow tits occupying the wet woodland. And then we have, in the lighter colours, the potential actions, so potential lowland heathland, potential wet woodland in the landscape. And so where the species, where the symbols occur, that's where they currently occur. And then what we do is, understanding the species dispersal limits, we project those species onto where we think they could occur if the actions were taken in the landscape. And importantly, we discount areas where the species couldn't get to based on our understanding of the dispersal ability. So, for example, the butterfly here, it couldn't actually cross, we don't think, this distance to occupy this new patch. So these patches, these unoccupied patches down here, don't count towards the species conservation targets. Importantly, we allow stepping stone connectivity in the model. So, for example, this willow tit here could actually colonize all these patches by hopping across the landscape to connect to a distant patch. And so by calculating these targets, we basically sum up the number of patches that we think the species could expand into. And that is used to calculate the progress made towards reaching the species targets. So has the species increased its population by X amount sufficient to meet the target you set previously? So then we evaluate the overall solution with respect to these three components. So there's a cost component, a spatial aggregation component, and a biodiversity target component. We actually allow the user to weight the importance of each of those components separately, so that if you're if you find that meeting the biodiversity targets is much more important than anything else, you can weight the model to say, ensure that you meet those targets. Don't worry so much about spatial aggregation or the cost. But if the cost is a really limiting factor here, you can set the cost to be the priority, and then the model weights more strongly towards meeting the cost. To lowering the cost. And then finally, we actually randomly modify this solution and then just repeat steps 2 to 6, evaluating whether the new solution is an improvement over the last solution. What we're actually doing here is only randomly modifying a subset of the sites within the solution. So you're getting almost a slight mutation of the solution. And then we reevaluate that solution using this function here. We're trying to minimize h of x. So when h of x is minimized, this means that there's lower cost, so it's a more efficient solution. It means the solution is more aggregated, so bigger and more joined up. And it means we're closer to meeting our biodiversity targets. So what happens in this model is we start with a really bad solution. So in this graph down here with the red line, you can see it starts off really high. And then we iterate over this process, looping through these steps 2 to 6, randomly changing the model. And progressively, we get a more improved solution. And eventually, when this black line and this red line meet, that means that we've met all of the biodiversity targets. So all of the species we've managed to reach the targets for. And then what we can do is carry on iterating the solution, making the solution much more efficient going forward in time. So let's look at an example of this. So if this is our initial solution, after a while, we might find a more spatially aggregated solution. So you can see the species become more, the patches become more clumped. More species find the patches accessible because they're within their dispersal distances. And you get more opportunities for complementary actions benefiting multiple species. And importantly, we also find more efficient solutions with respect to cost. But the cost trade-off is difficult because what it's always doing is it's saying, well, if the patch costs more, you might not want to include it in the solution. But in order to compensate for perhaps the biodiversity benefits that would be lost by not including that option, you might need to include more of some poorer quality land, some lower cost land, which might make the solution take up more land space. So the model is always trading off between trying to reach the biodiversity targets and trying to find a minimal cost and an efficient solution. So you run the model, you meet your targets, and you stop at some decision at some time point that you set up beforehand. So you might stop when you meet the solutions. You might stop after a certain number of iterations when you got no more improvement in the model solution. So we also need to account for the co-benefits of biodiversity, and our model accounts for, or can account for nature-based solutions. So I've already mentioned flooding. So we've included flood risk mitigation in our model before. Things like pollution, so runoff to rivers and roads, etc. We're starting to think about disease ecology. So how do you buffer wild populations from transmitting disease? We think about co-benefits in terms of food security and rural livelihoods, so diverting actions away from the priority land use and priority farming landscape and towards less valued farmland, and thinking about access to nature and climate change effects on species and environments. So all these actions can be and are being considered in this model. So I just want to briefly touch on a case study to demonstrate how the model works or what the model looks like in practice. So we ran a case study for the Lizard Peninsula, which is a special area of conservation in Cornwall. Used 34 conservation priority species for a broad range of taxa and 10 types of habitat creation opportunities. And what happens is you end up with a model iterating through, here we ran 200,000 iterations, and it starts off after 100 iterations. It's effectively a random selection of potential actions in the landscape. And after 200,000 iterations, what you end up with is the model aggregating, collecting actions around existing habitat and making sure there's connectivity across the landscape. And we can see here, like again, that the solution reached the objectives quite quickly, and then we iterated to improve the solution. So we have used this in practice again. So the case study was one example, but we've actually used this model to guide the local nature recovery strategy for Cornwall. So the local nature recovery strategy, Pip is going to talk about this later, but it's a system of spatial strategies for nature and environmental improvement required by law under the Environment Act. And what we use this model for is to do the mapping the specific proposals for creating and improving habitat for nature and wider environmental goals, which is a key component of the local nature recovery strategy. So we ran the model for, in the end, around 400 taxa from across species groups, from fungi and lichens to invertebrates, plants and vertebrates, across Cornwall, the whole of Cornwall at 200 by 200 meter grid cell resolution. And this is the final map that we produced. And what the map is doing is prioritizing land parcels into the types of opportunities that exist in the landscape. So we have in the red opportunities for wood and scrubland creation, in green species-rich grassland. And you can see that the model is very good at targeting and aggregating habitat into the landscape in a sort of ecologically sensible way. Pip is going to talk about that a bit more later. So where are we with Ebrel model development and availability? Well, the Ebrel R package is coming very soon on GitHub. And the important thing about this model, it will be fully open source. You'll be able to look at the raw code. You'll be able to download it and use the model yourself. We have a revised manuscript that's currently under review that explains the full technicalities behind the model. We have an exciting development. We're getting a natural language interface developed from the model, led by the University of Exeter's Centre for Environmental Intelligence. And that will be an interface where you can talk to the model and get the model to set up the spatial prioritisation for you and run the analysis. And then we have some research we're doing. We're currently engaged in a national scale analysis of priority actions for nature recovery across Great Britain. And then we've got some exciting research underway about equitable access to nature and renewable energy infrastructure and how that dovetails with spatial prioritisation for nature recovery actions. And those are led by our PhD students, Devmini and Anchi. So we're always looking for opportunities to use this model in a real world setting. It's a powerful model, it's very efficient. And if you're interested in using this model, I suggest you contact Ebrel and Rebio. And if you're interested in discussing any technical details with the model or with any suggestions about things you would like to see in the model, then please contact me. So that's some details about our spatial prioritization model. But how do we use that model in practice? This is a challenge we're dealing with following the local nature recovery strategy. Is how to implement these changes. And I'm actually going to hand over now to my colleague, Marcus Rhodes, who's going to talk about our tool, Rebio, which is a tool for guiding the implementation of conservation actions on the ground. Marcus.
Great, thanks, David. So as you've just been hearing from David, Ebrel is very much designed to kind of spatially prioritize at a kind of regional landscape scale. But having developed the local nature recovery strategy for Cornwall now, we're very much kind of shifting our focus towards the delivery side of things. And so that's kind of where Rebio, the second tool that we're going to showcase today, has kind of started to be developed. Because when you're actually coming to delivering nature recovery, you often want much more finely resolved information about habitats and species to help guide the decisions, for land managers on the actually on the ground. If we could have the next slide, please, David. So to kind of illustrate this point, let's consider a species such as the silver-studded blue. Now, one of the main habitats that this species uses is heathland. So in our kind of spatial prioritization, we will be allocating heathland across the landscape for this species. But on the right of the slide, you can see two examples of heathland here in Cornwall, but only one of these actually supports silver-studded blues, which is the bottom of the two. So silver-studded blue is a species that's right at the kind of northwestern edge of its range here in the UK. And because of that, it's really restricted to hot microclimates that are created by lots of kind of sparse vegetation, bare ground, and short sward heights. And so if you want to actually deliver nature recovery for this species, you need to ensure that those specific habitat features are included somewhere within your heathland kind of habitat that you're creating. So with this in mind, we've drawn upon an extensive sort of database that we developed as part of the local nature recovery strategy process. So when we were building our kind of database for Ebrel, we had a large consultation with lots of taxonomic experts, where we kind of drew up a long list of priority species for Cornwall, and also gathered information on things like their habitat requirements. And we've been kind of adding to that as well, information about kind of specific habitat features, the threats and opportunities for creating habitat for those species. And Rebio is really about trying to bring together that information into a really kind of easily accessible form for land managers to access. Next slide, please. So if we kind of imagine a kind of fictitious landscape where we have existing patches of habitat, our kind of what we're envisaging with Rebio is you can either sort of drop a pin on that map. So next slide, please. With a kind of buffer distance, or next slide, you can, if you have a particular land area you're interested in, you can kind of mark out the area of that across the site. And then using the modeling that we developed for Ebrel, and next slide, please, we obviously know which habitats, based on the kind of underlying soil conditions, climate, hydrology, it's possible to create within that land parcel. Next slide. And we also know we have information on biological record data and species distribution models. We also know, have a good understanding of where we think species are likely to occur at present across those sites. Next slide. And then using that information and species-specific trait data information on things like dispersal distance, we also know which species, if you were to create this particular habitat opportunity on your site, which species are likely to, heathland species could potentially benefit from the creation of habitat on your farm or nature reserve. Next slide, please. So we can repeat that analysis for multiple different habitats across the landscape. So for example, creating acid grassland or wet woodland, wetlands, whatever the habitat might be. And through that, we can essentially draw up a list of potential species that we think your site could be, strategically important for the recovery of. So this can kind of help land managers to understand what species their site might be particularly important for. Next slide, please. And then using that information, we can then present that as a kind of a range of options, essentially. So if you were to create a specific habitat in your site, which priority species are likely to benefit from that? So for example, if in this example, if you created heathland on your site, there are two kind of regional species priorities that could benefit. There would be one if you created acid grassland, and so on and so forth. But importantly, we're also providing information upon those specific habitat features that species might require. So you're only going to get your silver-studded blue if you create short sward and bare ground on that site. So it's designed to really help kind of tailor the management decisions and kind of help land managers to understand what the different effects on biodiversity would be from the different management options that they might consider upon that site. Next slide, please. So in the first instance, we have developed this for Cornwall, and the intention is for it to be hosted upon the new Local Nature Recovery Strategy Hub at Cornwall Council's website. And it'll be there as a kind of alongside the kind of species recovery toolkit and the habitat maps to kind of help inform the kind of fine-scale delivery of the local nature recovery strategy as we're moving to that next stage. We are, though, as kind of David mentioned with Ebrel as well, very keen to start expanding this nationally. And so we are looking for new opportunities where we could start developing Rebio. So if you think this is a tool that might be useful for your particular area, do get in touch with us. Eventually, our plan is to try and develop it, for the whole of England and Wales. And whilst we're on the local nature recovery strategy, I'm now going to hand over to my colleague Pip at Cornwall Council, who's going to talk a little bit more about how these tools have been used by the council to help them develop their strategy.
Thank you, Marcus. Yeah, it's really lovely to be here today. So I'm Philippa Hoskin, Nature Recovery Manager at Cornwall Council. So I was the senior lead for the creation of the new Cornwall and Isles of Scilly Nature Recovery Strategy. And we've also got Beth Roberts here from my team. And Beth and her colleague Dougie worked tirelessly with myself to generate our now published Nature Recovery Strategy with the support of the University of Exeter. And I should just say our strategy, we were really pleased to have it adopted in March of this year and then published very soon after. So I think my understanding is we were the third out of the 48 being created across England as we speak. And, you know, what's been really welcome has been some of the feedback since we've published, both in terms of the accessibility and the kind of hope that our strategy has provided, but also the usability of the maps. And that's what I'm going to be focusing on, obviously, mostly today. Just sort of running through a little bit more background to how we worked with the University of Exeter and other partners, but also some of the uses, both at a policy and strategy and project level, for which the maps are now being adopted, essentially. And I should just say our strategy was created in collaboration with our local nature partnership. Ilya sits on the board of that. And essentially, we sort of worked in almost like a commission sense with, or in partnership with the University of Exeter, who led on the creation of our sort of opportunity areas within the Nature Recovery Network maps. But I would just also like to thank our amazing environmental record centres and biological recorders network, who provided information and support and data to this, and it wouldn't be as good as it is without their support. I think we've got Emma on the call, and I'm just incredibly grateful for how we genuinely worked in partnership to pull this together. And for those of you that aren't as familiar as myself with nature recovery strategies, you know, the two outputs that are required are essentially a sort of narrative, so a strategy document setting out locally agreed priorities and actions, and then the nature recovery network maps. And you know, they have to be used together basically, and they have to speak to each other as well. So we tried with the functionality we had, we tried as best as we could to really ensure that they were used together. Yeah, next slide please, David. So I'm not going to talk too much about the strategy document and those locally agreed priorities. I would encourage you, hopefully someone will pop in the chat, a link to, we've got a Nature Recovery Hub with all of the sort of projects and activities and partnerships and who were involved in creating these documents, but also you can access all aspects of our strategy if you wish to take a look at that. But, you know, there will be some very familiar locally agreed priorities and themes, which I'm sure we're also seeing played out across others of you involved in LNRSs in other regions. Things like, but for example, some of them are always particular to Cornwall as well, like the, you know, continuous coastal wild belt, etc., and Forest of Cornwall, which is one of our strategic projects. Next slide, please. And we, with our Nature Recovery Network, we chose to use sort of plain English and make it as absolutely accessible and user-friendly as possible. So we used terminology that we felt people could connect with. So we have two zones in our Nature Recovery Network. Zone 1, which is essentially set by government, because for LNRSs we had to follow statutory regulations and guidance to ensure that consistency across the country. So that's largely made up of those designated sites, regardless of condition, and those that have a sort of role within the planning system. So zone 1 is quite fixed. It only goes down to mean low water, but we are creating a separate but aligned voluntary marine nature recovery framework following the same sort of methodology as the LNRS, but a different approach with the mapping. Zone 2 is what we've all been talking about today, essentially. So this is what was created with the University of Exeter in a very iterative approach with our stakeholders. You know, some of the guidance coming from government and the requirements came out through the 2-year or so, 18 months to 2-year process. And we also at each stage had to kind of wanted to really reflect on stakeholder and that participatory feedback as well. So it was a real combination of evidence-led combined with sort of stakeholder and expert views. Next slide, please. And I should just also say, sorry, that for those of you, you know, I hope many of you are very familiar with LNRSs, but I think, you know, I was involved in Cornwall's first biodiversity action plan. We've moved on a long way since there. This is about going above and beyond the usual protect and enhance, and Zone 2 in particular exemplifies that need to look for opportunities for genuine creation to increase extent, because our current approach isn't working. We need to go much further and deliver a nature recovery over a wider area alongside other existing land uses like renewables, housing, farming, etc. In terms of our nature recovery network, you know, Zone 1 covers about 15% of Cornwall, and the overall network just inches above 50% of Cornwall's land, Cornwall and Isles of Scilly land area, bearing in mind goes down, as I said, to mean low water. There is overlap that mostly relates to our local sites where condition isn't known, as well as I think the intertidal triple SIs appear in Zone 1 and Zone 2 and such like. And there's a broad breakdown there showing the makeup of our Zone 2, and you'll see that a proportion of it was informed by that incredible systematic conservation planning outputs, which ran over, I think, was it 6 months? I think it's all a bit of a blur these days, about 6 months. So it really tried to look for the most efficient use of our land area through the methods described there earlier by David. But that was then topped up with these post hoc additions to our nature recovery network Zone 2. So these were much more expert led. So for example, systematic conservation planning the data wasn't there to use it for the rivers, so we had to use a more participatory approach to decide on our priority rivers, for example. But also things like some of the coastal wild belt, they were locally agreed requests that was added. So about 60% of the Zone 2 was made up from the modelling, but then you've still got that human decisions, and all of the details of the decisions, the weightings, the evidence, the data used, etc., are all set out on our Nature Recovery Hub, explained in a very detailed methodology, you know, which we created with the university to try to make it as open and transparent as possible as to what went in. It wasn't just some black box, you know, it was very much sort of human-led, as well as, you know, using the sort of clever powers of the modelling. Next slide, please. I've now been asked, you know, to really give you a flavour of some of the ways that the Nature Recovery Network mapping is being used in practice. So just to start at a sort of policy and strategy level, and in particular in relation to planning, and which is one of the key sort of functions of LNRS. It's not the only thing it's been designed for, but the LNRS maps, and particularly the Nature Recovery Network maps, have to work with the planning system, which is why the maps are fixed. And in particular, you know, Zone 2 provides a financial uplift if you deliver the preferred action in terms of any net gains schemes within Zone 2. So it's got to work within the existing planning system, and we're working with our planning colleagues and provided some guidance for them about how the Nature Recovery Network map and strategy should be used to inform planning decisions, because it is now as it's adopted, our LNRS is a material planning consideration. But also Cornwall Council's gone further in that, and we've had a climate emergency development planning document for a number of years with nature recovery policies within that. So we've again provided guidance on how that should be interpreted in a practical and proportionate way. But looking to the future, our strategic planning colleagues, they're getting ready for the next review of our local plan. Obviously, there's a lot of changes with the planning and infrastructure bill at the moment, but they're hoping that the plan will commence within the next year. And we've had workshops with them about how the LNRS can inform the local plan, but also how the local plan can actually help deliver on the nature recovery strategy priorities and places. For example, we're going to be running calls for sites for biodiversity net gain with our planning colleagues, but they will be aligned with the LNRS map. So really trying to prioritise net gain sites within the Zone 2, for example. We're also looking about whether the Zone 2 could be further prioritised to allow for some spatial allocations for nature. So the really sort of creme de la creme of Zone 2 could form spatial allocations, rather like we're used to having spatial allocations for housing or renewables. We feel that not all of Zone 2, but a proportion of it, there's justification to have as a spatial allocation in the local plan. But also, you know, it can help identify where you can have co-location with other activities. A lot of these aren't mutually exclusive. And what's been great about the way that the modelling was developed and the inputs and the weightings put into it, it also tells us where we get the biggest bang for our bucks in terms of if we deliver for nature, we're also delivering the best nature-based solutions to protect and increase resilience of our communities, for example, through things like natural flood management and carbon sequestration. Next slide, please. We're also using the maps to inform project development, but also we, DEFRA have recently tasked all responsible authorities with essentially creating project pipelines, which we'll be showcasing on our Natural Capital Exchange platform. But they will be guided by the Nature Recovery Network maps. And we held a workshop as well with our strategic conservation partners to really, with ILIA, really challenge all of us to look at our assets and our projects to see we need to do more for nature and really how we can up the level of ambition and genuinely transformational change to turn the tide for nature, but really guided by those LNRS maps. And it's very interesting. Marcus did some work just getting some of the conservation sector's assets and the council's assets alongside the LNRS maps. And it's amazing what it reveals in terms of what more we can be doing collectively. Next slide, please. And, an example of where we're using it to sort of guide project prioritisation, which is what the maps are in part for. We can't do everything everywhere. We have to focus our efforts. Cornwall Council's leading on an ambitious catchment scale project, Foul Rivers to Reef, which also goes into the marine area, really looking to maximise nature recovery and nature-based solutions within this catchment. And that was driven by the fact that when you look at the county, this area was screaming out in terms of significant opportunities, but also landowner willingness to really get involved. So we've got a farm cluster forming, but the maps can also guide self-initiated farm clusters and neighbours to work together and have conversations, together. It doesn't have to be led by an organisation as such. So really encourage that bottom-up approach as well. Last slide, I think. And I just wanted to end, we only published in April, and already myself and the team have had some amazing feedback nationally and such like, but also locally. It's so heartening to us to hear from colleagues, from partners about how they're using the maps. And for example, FWAG, they were out on Bodmin Moor, working with farmers. They were just about to kind of commission some opportunity mapping. And then they went, hang on a minute, should we have a look at the LNRS maps? And basically the farmers were like, oh, this is great. This is exactly what we need. And it's already guiding those conversations. It doesn't replace site surveys and much more detailed conversations on a site basis, but it is definitely informing projects. It's informing the council's asset management review and our own delivery plan that we're creating. And also what was most heartening, literally last week, South West Lakes Trust got in touch to say that the maps alone helped one of the key people there to change and inform their business case to convince her colleagues that an area that they were going, oh no, it's hopeless, don't be ridiculous, you can't do woodland regeneration here. The combination of the maps and evidence on the ground meant that she had enough evidence to convince her colleagues that an area near one of the reservoirs was suited to woodland regeneration. So, that is what I want to hear. They're being used. And the way that the university worked with us in such a practical and iterative approach was absolutely second to none. So I'd thoroughly encourage you to work with them if there is an opportunity, and we are immensely grateful and happy to answer any questions. But do please look at our maps and strategy through the links. Thank you.
Great, thanks a lot. And yeah, thanks Pip, thanks David, thanks Marcus. That was excellent. Nice to be reminded sometimes of all the brilliant work you guys are doing. So we got lots of questions posted in the Q&A. Do just keep them coming if things pop into your head. But what I'm going to do is just run through them. I've tried to sort of order them a little bit, and I'll probably hand over to sort of various people in the team to answer some of them. So one of the first questions we had was interested in what is meant by track changes in land use, habitat and species, so that biodiversity renewal is informed by the best available evidence. So this essentially was in one of the early slides where we were outlining what our kind of broad objectives are within theme 3 of Renew. I think those exact words were used, and it's probably just something we put in the grant proposal at the time to help us get funding. But I mean, really what we mean by that is, we want to know how much habitat there is in areas, how the quality of the habitat is changing, what the trajectory of different species is in a particular location. Now, in terms of actually how you make use of that evidence or what is evidence, it really depends on the context. But I mean, in much the same way as you might, if you were buying a bicycle or a car, want to know the price of the car or the bicycle. If you go to a site and you've got the possibility of doing a certain conservation action, you would ultimately want to know whether it works. Is it a kind of habitat that species that you would consider to be important? Are those species in the surrounding area, or would it work? But yeah, so that's really all that we meant by that. There was lots of sort of questions about the cost layer, actually, and I'll probably hand over to David for a little bit more detail on that. But the important point to emphasize, the tool itself doesn't produce the cost layer. What it is it's one of the inputs into the tool. So the tool, the way that we've talked about it, is very much either in a Cornwall or a national context. Actually, the tool itself is essentially a set of rules that could be applied anywhere in the globe. And obviously, the costs that you might put in if you were working in South America would be very different from in the UK. Now, when we used it in the Cornwall context for LNRS, we actually just did something very simple. We just simply used the agricultural land grade as the costs, but we are now working with colleagues at the university who work in the Land Economics, Environment and Policy Institute to essentially see about the ways in which we can integrate some of the quite detailed modelling that they do that uses data from the kind of Farm Business Survey and via DEFRA that actually sort of comes up with predictive monetary values for how much an individual might farm gain or lose by a given set of actions. We're exploring ways to integrate that. And I don't know if you want to just say a little bit more about that, David. You've been more directly talking to Amy and colleagues.
Yeah, I mean, not much more to add, but I just said that through the cost function, you can actually be quite clever and add quite a lot of different factors via that function. Although it's called the cost function, it's actually just a weighting function that allows you to weight different land parcels by some metric of whether whether they should be preferred or not. So you can have costs as an economic costs of buying and managing land, but also this costs can be, like I said before, they can be positive costs. They can be benefits, as it were, to taking an action in a particular place. And mathematically, it's all integrated and sorted out in the maths. But so it's a function to help you weight different decisions based on some idea of cost and benefit.
Yeah, and that actually leads on very logically to, there were several other questions which were a bit related to that, which I've kind of grouped. So just tackling some of the specifics, could you incorporate things like invasive species or deer management? Yes, if you can come up with some cost for those, then they could be added to the cost layer. They could be put in. Exactly how you do that would need to be worked out. The tool itself wouldn't answer that. Then there's a question around, do you consider species that may be disbenefits? Yes, exactly in the same way. It would be handled by sort of feeding it into the cost layer. And then also David talked about the way that you can have the inverse of costs, essentially opportunities. So one of the questions was, can you envisage a way in which non-species targets could be integrated? So that's things like, air quality, flood mitigation, things like that. And that's precisely what we mean by the kind of inverse of a cost. If you have some other layers that might, for example, tell you something about the flood mitigation potential of a particular habitat creation option, or you might have something, for example, on carbon or other things, then yes, that's the way it would be incorporated. I don't know if you want to just add anything really on the specifics of that, David, or...
Yeah, so carbon was an interesting one because we looked at carbon mitigation, and that was actually integrated by both a cost and as a feature in the model. So we set a target for achieving a certain sequestration of carbon through habitat, and we had estimates of how much each habitat type could sequester, and then we could actually run the model to try and optimize that in the model. So these, yeah, and you could do a similar thing for trying to mitigate pollution. So.
Yeah, thank you. And so there was a question as how does Ebrel integrate with local nature recovery strategy and land use framework? I think the question was posed before Pip spoke about, or David mentioned, the Cornwall and also Scilly local nature recovery strategy. So I hope we've answered that question to show that indeed it's highly compatible with LNRS. Of course, one of the challenges of LNRS is that the different parts of the UK are all taking quite a diverse approach, and it'll be kind of interesting to see how the end aggregation of them all ends up. But Marcus, you were quite involved in poring over the land use framework. I don't know if you want to say anything about integration with that, or the soon-to-come framework, we should say.
Yeah, I can have a stab. So I guess one of the slight challenges with developing the LNRS is that it's kind of come before the land use framework. So we're kind of, when we were setting our kind of target, for example, one of the difficult questions we had to try and address was actually how much land in Cornwall should you be allocating to nature recovery versus, Cambridgeshire or Cumbria. And so, I mean, to be honest, we've had to take an educated guess, given based on the kind of the relative contributions of agricultural land grade, etc., and the importance of species here. But essentially, what you kind of want the land use framework to deliver is that kind of guidance for kind of local planning authorities to give that kind of idea of how much land should be allocated, and then you can use that as your basis for then Ebrel as your to kind of work out how much land the model should then be trying to optimize. So I think there's a lot of potential going forwards for them to work really nicely hand in glove. Also kind of thinking nationally with the development of the land use framework. Obviously, we kind of have two main strings to biodiversity targets. One of them is kind of area-based, 30 by 30, but then we also have our biodiversity-based targets on halting biodiversity decline by 2030, and then increasing biodiversity by 2042. And as far as I'm aware at present, I haven't seen any analysis that's actually tried to understand, well, how much land allocation nationally would be needed to meet those targets, and also how that would need to be spread across the country. I mean, I do have some concern at the moment that there is this idea that, we can do nature recovery in the bits of land that aren't good for anything else, when actually nature recovery is probably the single most spatially sensitive land use there is. And you do kind of need to be taking that kind of distribution of species into approach. So I do think there's work we could do with Ebrel to help guide the land use framework in terms of actually understanding how much land needs to be allocated for nature recovery and where across the country that would need to be done.
Okay, thank you. So there's also interesting question here about how does a habitat like wood pasture get incorporated into the model that may include open habitat and tree scrub, and essentially what it's a sort of, if you were to sort of frame the question another way, it's basically how do you put in those kind of integrate habitats that might be more than one thing, or a mosaic habitat or an edge habitat. And it's important problem that we've been sort of battling with a little bit, and I'm not sure we've perfectly got the answer yet, but we are thinking about it hard. And so essentially, if you just sort of summarize briefly how the model works, you put in a whole bunch of maps of where species are, and you basically consider where the options for those species to go to, given the dispersal range and the options for creating the different habitat types. Now, how you define those different habitat types could be quite broad. So it could be that you just sort of lump everything like woodland, grassland into one category, all types of grassland, all types of woodland into one category. It could be really specific. It could be things like you differentiate between ancient woodland, wood pasture, kind of, you're a lot more specific about your different habitat types. And there's trade-offs with both of those. If you keep your habitat types broad, it has two advantages. It essentially makes it computationally more tractable problem, although I've been told the gains aren't necessarily that big. But actually potentially more important if you're advocating for a particular action that involves actual habitat creation, one wouldn't necessarily want to be too prescriptive about that. One could envisage propositioning that a particular sort of broad habitat type is there, and then it would be up to the kind of land manager to or whoever actually carries out that intervention to decide exactly what flavor of habitat they need. And in fact, that's what the Rebio tool is seeking to guide with. So, I mean, in essence, you could very simply put it in as a kind of broad habitat class, as its own habitat class, and then it would deal with it that way. Or the other way, what you can do is basically, if any species needs that particular habitat type, you just make sure that what the species actually needs is mapped onto what you're actually potentially advocating as habitat creation. I don't know, Marcus, you spent a fair bit of time thinking about this, didn't you, and actually how it pans out in the Cornwall LNRS. Do you want to say a little bit more about that? Or
yeah, so for the Cornwall LNRS, we actually mapped wood pasture and scrub grass and mosaics as their own broad habitat type. I guess particularly because there is a lot of interest around the kind of NEP style models of habitat restoration, we thought, that's a habitat that it would be useful to actually kind of map. So you're kind of, obviously there are species that need that kind of mosaic, but then you've also got some species that, are associated with grassland, but then can use that, and other species associated with woodland that can use that habitat. So obviously multiple, species can have multiple different habitats that cater for them. And so that's kind of considered as part of the optimization within the algorithm. But yeah, for the Cornwall LNRS, we actually specifically mapped it as its own habitat type.
okay, thank you. And so there's an interesting question here of how did the map for Cornwall LNRS produced by the model differ from what would have been produced by species experts and other local expert knowledge in the absence of essentially the application of the tool, I guess. I mean, we didn't directly do that comparison. There's several reasons why one might be hindered from making that comparison. I mean, firstly, actually, one of the very first things we needed to do before we even started the application of Ebrel was model the distributions of species. Now, most biodiversity data collected in the UK is collected by volunteer citizen scientists, and they're very good at recording where they see things. They're less good at recording where they don't see things. So what you end up with is a bunch of records where we know things are, but with often very big gaps in them. And in fact, for example, if you just overlay the raw species records for Cornwall, as I've done in the past, you've come up with a kind of biodiversity hotspot, which just happens to be the back gardens and the surrounding area of the two biological recorders in Cornwall. So, we know that actually there's a piece of work that needs to be done moving from raw records to sort of objective maps. So, I mean, the first part of the answer is actually because simply nobody knew the distribution of all of these species. Undoubtedly, our biological recorders would have known, some of the distribution of all of them, or some, and probably all of the distribution of some of them. But I don't think anybody actually knew where they all occur, and that's really the baseline information that you need. Now, after that, actually, all the tool is really doing is making probably exactly the same decision-making process that a human would do. It's nothing sort of dark arts about it or black box about it. It's just going through exactly the same thought process as a human would go through. Basically, I've got these two options for habitat creation. Should I do A or B? And in many instances, if that's a relatively simple problem or a sort of over a fairly small area, of course, a human could make that problem, could answer that perfectly well, perfectly, intuitively. Now, the trouble is, if you're doing that over hundreds and thousands of land parcels, and making all those kind of manual decisions, and you're potentially sort of trading off several hundred species, there's an advantage of just getting that decision made by, well, not the decision actually made by the computer, but all the computer is replicating exactly the same sort of thought process that a human would make, but doing it really quickly. So, I think the point is, I know there's sometimes a little bit of a mistrust in sort of computer tools and things like that, but actually just to recognize that, that's absolutely all it's doing. Actually, it can just do it quickly. So my guess is, probably they would have differed slightly. There would have been a high degree of overlap, but we didn't do that exact comparison. I don't know if you've got your hand raised. I guess you want to come in on this point.
Yeah, I don't know whether David wants, much as I love having our link to our Let's Talk thing up there, I don't know if David wants to just stop sharing, but I just wanted to say, Ilya, like in my career in conservation here in Cornwall, I think I do have a pretty good idea of what it probably would have looked like if we'd done it 100% through expert sort of participatory processes, because that's a lot of how some of these things have been done in the past. And I think that, not withstanding the sort of details that you just set out, I think we would have just seen areas put forward that are often the sort of usual suspects, that are already getting a lot of attention from the conservation sector. And I don't think we would have seen that detailed connectivity that we get through the maps that you've produced for us by any means, and that sort of granularity, and really sort of building on what the species require rather than just let's work in this area because it's good for biodiversity. I think there'll be a lot of differences that we would have seen, but I think what we've tried to do, and I hope I got across, is it was using the systematic conservation planning as the sort of skeleton for our nature recovery network maps, but then we worked with experts to iteratively change some of the decisions or weightings and or add to it with those post hoc amendments. So I think we got the sort of best of both worlds, recognizing that the computer and the model can only go so far, and that our local experts absolutely have some knowledge that they need to input. So yeah, but I think it would have looked very different and more simplistic, I would imagine, if we'd done it purely through not because the stakeholders are simplistic, but because our level of knowledge and detail of individual sites and mosaics and such like would have been a lot harder to translate onto a map.
Yeah, and I mean, it's an important point is obviously a human can always make more known decisions at a kind of local scale than a computer which applies the one size fit all. So, you've got to blend the two really. So just in the interest of time, we've got a couple of questions. One which I should be able to answer quite quickly, which is simply where did the data that we used for the LNRS come from, and or in the application of Ebrel to LNRS. So habitat data, it was an amalgamation of various sources that David can talk through in a sec, but the species data came from both our local record centre, the ERCSIS Environmental Record Centre for Cornwall and the Isles of Scilly, and then a range of other sources, including sort of open sources like eBird, but then we've also got kind of plant recorders that are slightly separate to there's sort of another record center that isn't quite part of the official record center that we also got data from. I won't go into the backdrop of all that, but we basically got all the records from the usual sources. And then, yeah, there's the habitat opportunity and then the habitat layer. Do you want to say a bit about both of those, David? Or
Yeah, sure. So the underlying habitat layer, the existing habitat, is based partly on the CH land cover map, but then augmented with any additional information we could get about priority habitats and the woodland inventory. And then the habitat opportunity layers were created in collaboration with the Devon Record Centre or the Devon Wildlife Trust, who developed a map, a lookup table that links particular habitat types to soil and hydrological conditions, and those underlying data were developed from the soilscapes data from Cranfield University. So using a range of the excellent data products we have available to us in the UK. So.
yeah, we're really grateful to the LNRS team in Devon actually for the habitat opportunities mapping that we did, because they'd got a lot more further with it than we had, and we were hopeful of getting a national data set, and then that didn't materialize for various reasons. Unfortunately, they were willing to allow us to adopt, provide us with the data sets that we needed for adopting the approach that they'd used. And yeah, I don't know if it might be worth actually just popping a link to the Thor's data set as well that we used, the open access trees, hedgerows and woodland one that was produced at Exeter. But another question, realizing rapidly running out of time, but is climate resilience accounted for in the opportunity mapping? Unpick that a little bit. It can be, it was, and not maybe the time horizons aren't totally appropriate in all instances. But what I mean by that is the species pool that you put in is ultimately a kind of human decisions that's taken with stakeholders. And in the particular Cornwall case, for example, we made the active decision to not include some species that we felt were just, really sort of doomed imminently, if not already, because of climate change. And I'm particularly referring to ring-ouzel here, which still, or I think, sporadically bred on highest elevation parts of Cornwall in the last decade, but is pretty much gone and probably just isn't worth investing the effort in. And then, we did actively include other things that have much more recently started breeding us, which said things like firecrest, which has been rapidly establishing itself as a common breeder in Cornwall. In terms of climate resilience, I mean, the opportunities that you're proposing for species, they're always within a sort of easy dispersal range of those species. So in terms of thinking about climate resilience, in terms of are the habitats actually allowing species to move because of climate change? Yes, you're doing it through that way. What you're potentially not doing, although there's no reason that the tool itself couldn't handle this if you provided the appropriate input data, is essentially providing some kind of weighting to upweight towards places that we suspect would house species into the future and disweight against ones that wouldn't. Partly because actually there's an awful lot of evidence to show that if you manage things appropriately in situ, you can usually actually offset the kind of climate impact that you would expect over quite a sort of number of decades. You know, climate always acts in synergy with other drivers of biodiversity decline rather than just in an isolation. And probably the easiest thing to do for climate change is just benefit the species in other ways. So in some ways, what you don't want to do is, you know, have something that doesn't allow you to do that. And so, yeah, so that was really the rationale we've taken. I think, unless I may have missed some recent questions.
Yeah. May I suggest that anything we haven't, I've put all of your contact details in the Q&A. So maybe if we haven't quite got through all of the questions, people can follow up directly by email. I'm just conscious of time.
Yep, I think we have actually. There's one comment rather than a question, but I think actually I've just covered everything, so it's good timing. But yeah.
Well, shall I just quickly give a shout out? So we're hoping to run some more webinars about Renew in the autumn. So if you're interested in finding out about other bits of work going on, I'll just pop the link to our events page in the chat. So this is where you should keep an eye if you're interested in engaging further. So we hope they'll be coming out through the course of the summer. So autumn time will be our next events for the project. But thank you everyone for coming today. And Ilya, do you have any final closing words at all?
Just to say thank you, and yes, of course, we're really interested in working with people. You know, this kind of scientists working in silos without thinking about how things are delivered on the ground just doesn't work. And so, you know, do get in touch if you think you can see an application for this kind of work, particularly the Rebio tool. You know, loads of scope to sort of feed into the way that that's developed. So yep, just get in touch if you're interested, or if you want to follow up any of the questions in more detail. Very happy to cater for that. But yeah, other than that, just thank you for joining.